Welcome to a new episode.
Hello and welcome back to the Convection podcast with me, as always, your host Chris Bailey. We've just kicked off our level 2 plumbing revision mini-series designed to help you tighten up your knowledge, boost your confidence and walk into that exam fully prepared. Today's episode we're diving deep into electrical and scientific principles, and I'm going to be honest, this is a big one. We're not just skimming the surface or reading the spec, we're breaking down the how and why behind each key part of the system, so you actually make sense on site and in your exam. Many students look at this unit as pure science, but the secret to passing is relating every element to the real-world plumbing situation. Whether you're listening on the bus, in a van, or in the workshop, this episode is built to help you lock in the technical details, avoid common exam mistakes, and understand the science of plumbing from start to finish. So grab a brew, get settled in, and let's get into this week's episode. Okay, let's start with the building blocks and material properties. Imagine you're standing in a merchant's yard. Every pipe, system and fitting you pick up has been chosen because of its physical properties. You need to remember how these materials behave under stress for your exam. First, think about tensile strength. Imagine a Munson ring hanging from a ceiling, holding up heavy run of pipework. That pipe is being pulled and stretched by gravity. Tensile strength is the material's ability to resist being pulled apart. On the flip side, we have compressive strength. Imagine the legs under a bath. When the bath is full of water and a person, those legs are under massive pressure. Compressive strength is the ability to withstand being crushed. Then we have hardness, which is simply the ability to resist scratching or denting. Remember that diamond is the hardest material, but for a plumber, ductility and malleability are the ones that really matter. To remember ductility, think of bending copper pipe. Copper is very ductile, meaning it can be pulled and stretched into shape. Don't confuse ductility with malleability. Malleability is the ability to be formed by a compressive force, like hitting, hammering, or bossing. Lead is a classic example for malleability because it can be bossed into complex shapes without breaking. Finally, we have conductivity. Copper is our superstar here because it has excellent thermal conductivity for hot water and excellent electrical conductivity for wiring. Now imagine that system is installed and you turn the heat on. Everything starts to move. This is thermal expansion. Every material expands when it gets hot and contracts when it cools. If you don't allow for this, you'll hear those annoying creaky noises under floorboards where notches are too tight. Plastics expand the most out of all the plumbing materials. The exam will often ask you to calculate exactly how much a pipe will grow. The formula is length of pipe times coefficient of expansion times temperature rise. When doing this calculation, always use the temperature rise, not the start or end temperature. If the start temperature is 15 degrees and it hits 60 degrees, your rise is 45 degrees C. Also, watch your zeros. The plastic expansion rate is 0.00018, while copper is much lower at 0.000016. Now let's look at the water inside those pipes. Water is a strange substance. It is at its most dense, meaning its molecules are as close as they'll ever get, at 4 degrees C. Or a simpler way to understand it, dense, weight, heaviest. So water is at its heaviest at 4 degrees C. When water freezes at 0 degrees, it actually expands by 10%. This is why pipes burst in the winter. When you heat water up in a cylinder from 10 degrees to 95 degrees, it expands by about 4%. So you might be asked to work out 4% expansion in a cylinder. If you have a 100-litre cylinder, 4% of this is 4 litres. That expansion has to go somewhere, usually into an expansion vessel or back up to the cold feed. We also need to talk about how water behaves in tight spaces. Capillary reaction. It's what draws solder into a joint, but it can also be a nightmare in an S-trap if it pulls water seal out. Then there's adhesion, water sticking to the pipe, and cohesion, water molecules sticking to each other, which creates surface tension. So imagine a cold water storage system in the loft. The height of the water above the tap is what we call meter head. The greater the head height, the greater the pressure at the tap. Pressure is defined as force over area. In the SI system, we measure this in pascals, or PA, where 1 pascal equals 1 newton per square metre. If a customer complains of low pressure at a base, you have 2 main levers to pull. You can increase the pressure by raising the cistern or adding a pump, or you can increase the flow rate by using a larger pipe diameter. But remember that friction is the enemy of flow. Elbows offer much more resistance than machine bends. If you have a choice on an exam question, always pick the route with fewest elbows and the smoothest bends to maintain the best flow. Now let's have a look at heat transfer and power. How does the heat actually get from the boiler to the person in the room? Well, there are 3 methods you must know. We have conduction. This is heat travelling through a solid. Think of holding one end of a copper pipe while soldering the other. The heat travels the molecule to molecule right up to your hand. Then we have convection. This only happens in liquids and gases. Hot water becomes less dense and rises, while cooler, denser water falls. This is how gravity circulation systems work. And radiation. Heat travelling in straight lines via infrared waves. A common exam trap is asking how a radiator heats a room. Even though it's called a radiator, it only radiates about 15% of its heat. The other 85% is actually convection, heating the air, which then rises and circulates. We also distinguish between sensible heat, where the temperature rises but the state stays the same, like heating a cylinder, and latent heat, where the state changes but the temperature stays the same, like turning water into steam. Finally, we'll have to talk about the sparky side of plumbing. Everything is made of atoms, and electricity is the flow of electrons from atom to atom. You must know your 2 main triangles. First of all, we have the power triangle. P equals IV. So that's power in watts equals current in amps times voltage in volts. Then we have Ohm's law, which is V equals IR. So voltage equals current times resistance, and resistance is in ohms. If the exam asks you to find the correct fuse size for a 3 kilowatt immersion heater, use the power triangle. 3000 watts divided by 230 volts, which is the standard UK domestic voltage, gives you roughly 13 amps. For safety, we use MCBs, which are miniature circuit breakers, to protect the circuit from overloads, and RCDs, residual current devices, to protect people from shocks by detecting imbalances. As a plumber, you must understand quick potential bonding. This is the green and yellow 10mm cable that connects your pipes back to the main earth bar. If you're cutting into a pipe, you must use temporary continuity bonding, the clips with the cable, before you cut. This maintains the earth path and keeps you from becoming the easiest path for electricity to reach the ground. Okay, so that brings us to the end of this week's episode of the Conduction podcast. We've covered a lot of ground today, from molecule density of water at 4 degrees and the way an RCD protects a circuit. Electrical and scientific principles can feel like a lot of random facts, but when you start seeing the science in the van or on the job, it all clicks into place. You've got the knowledge, you've got the formula, and you've definitely got the ability to pass this. Take these tips, keep them in the back of your mind when you're on the side, and you'll smash that exam. Thanks for listening to the Conduction podcast with me, as always, Chris Bailey, and I will catch you on the next episode where we dive into the next stage of your level 2 journey. Good luck with all your revision, and we will see you on the next episode.
We'll be back next week. In the meantime, please subscribe and thanks for listening.